Okay, for starters, although you can put this into one thing, I'm just going to separate it into two energy diagrams so that it can be simpler. Okay, we have two of them because, first of all, there's two types of energies. There's potential energy and kinetic energy. I don't know if you remember that they have indicators, but for kinetic energy, it's velocity, and for potential energy, it is distance or the height of, or the height, I bet. Okay, so first of all, you're gonna put distance initial and distance final. And same thing with the velocity. Velocity initial and velocity final. Okay. Well, excuse me. For kinetic energy, what we're going to do is, kinetic energy is obviously the energy of the total movement. Okay. Throughout the project, okay, so here's the building, and this is us. Okay. So, and then that's the tarp or whatever that the projects were supposed to fall in. Okay. So throughout the event, our projects over time, they increased in velocity. So the velocity in general, sorry, let me write that down. The velocity in general, it went up, right? Okay. However, the initial, obviously, velocity is 0 because we're only starting out. It's in the air and nothing's happening to it until we obviously let it drop. That means that the velocity final, well, you're supposed to find that in question 5, so just leave that. Just put that, whatever you got in number 5, in there. And then for the kinetic energy, well, it's obviously increasing as well because its indicator velocity is also increasing. Okay, now for potential energy, it's a little different. Okay, so back to the picture. When the box was high up in the air, it's there, right? Okay, but then over time, it's going to go back to the ground. That means get the initial distance was 10 meters. Miss Nee told us it was something like that. And then the distance final would then be 0. Why? Because the project from the 10 meters keeps dropping and dropping until it hits the ground. Or in other words, 0. Right there. Okay, from there to there. Okay. And then that means that the distance goes down. And if the distance goes down, and it's an indicator for potential energy, that means the potential energy also went down. Okay. And here comes the conservation statement. Okay. So, let's see.